So let us see on how we can be able to have the sum of terms in a geometric progression. So now there are two formulas associated with the sum of terms in a geometric progression based on the nature of the value of the common ratio. So now we have the first formula, which is given as sum of any terms, and which is given as, let's say, a sum of any terms, and which is given as the first term, and it times actually times 1 minus r to the power n, and divided by, we have it as 1 minus r. And this formula is basically used whenever r is less than 1, and that is when r is let's say 0 something. That's when this formula is basically used. So this is used whenever r is less than 1. It can be 0 something, or can be even the negative number. So, and we also have another formula, and which is basically used. We also have another formula which is basically used as summation of any terms, and which is equal to the first term, that is r to the power n minus 1, and that divided by should be r minus 1. And this one is basically used whenever r is greater than 1. So these are the formulas associated with a sum of terms in a geometric progression. So just have to look at the nature of the value of r and see which formula can be used to have the sum of terms. So keep that in mind. Let's say we have this kind of the geometric progression series, which is given as, let's say, 32. Let's say we have it as 32, and we have 16, and we also have 8. And assuming that the city can keep on going up to the infinite. So now find the sum of, let's say, 20 terms. Summation of, let's say, 20 terms, if this is the case. So now first thing, we should have to look at the first term. What is the first term? The first term is given as 32 in that case. And what is the common ratio? The common ratio is given as 16, and divided by 32, and which is the same as 1/2. So now as you can see, we have the common ratio which is less than 1, and we have the number of terms which is given as 20, because we are sure to have the sum of 20 terms. So what would be the formula to be used to have the sum of terms? So now, since the common ratio is less than 1, then that means we are going to use, in this case it means we're going to use this method, this formula. Sum of n terms is equal to the first term, and that is 1 minus r to the power n, and that divided by 1 minus r. The thing is that we are trying to avoid the negatives. So in this case, we just have to substitute sum of 20 terms. That is the same as, what is the first term? We have it as 32. So the first term is given as 32, and the times we have 1 minus, the common ratio is given as half. That is 1/2. Then to the power, actually 20 corresponds to the number of terms. And overall divide by, and that should be 1 minus half. So we'll have that understood. Then next we should have to, we'll have what is 1 minus half, that is here, and what is actually that one. So just have to do things actually step by step to avoid some typical errors that comes in whenever we are rushing doing things. So we are looking for the sum of should be 20 times. That is equal to, we still more have 32 here. The times 1 minus, now we have 0.5 to the power should be 20, because 1 over 2, it is the same as 0.5. So 0.5 and to the power 2 should be to the power 20. So in this case, that is to the power 20. You know, we'll have it as a very, it should be the smallest number. That will be given as 9. Of course, we'll have it as 9 point, should be 5, 4 times 10 to the power, let's say negative 7. So it should be this. So times 10 to the power negative 7, like that, and that divided by, so 1 minus half, it is the same as half, which is corresponding to 0.5. So we'll have that as that. Then I want to go up next. So in that case, we'll just have to simply divide 32 divided by 0.5. Now we'll have it as 64. That is like this, so have it as 64, and the times, and I also have to subtract inside there. So which means we'll have 1 minus, so have 1 minus, that should be 9.54, and the times 10 to the power, that should be negative 7. So in that case, we'll have it as, so in that case we'll have it as, and that should be 0. Should be 9, can be 9, and we have about, and we have another 9, 9, 9, and in that case actually is 0.46, and the times 64, that will be given as 63, should be 63 point, now should be given as 63 point, we have it as 9, 9, 9, and 9 actual 4. So this is the sum of actually 20 times, and for this typical actually geometric progression series. And also try to have the sum of, let's say, a 60 times in the same way, and also try to have the sum of, let's say, 70 times, and for this typical geometric progression series. Now how about we have this one? Let's say we have 9, negative 6, let's say, 4, in this case. Let's say this is the case. Now what is the summation of, let's say, 30 terms, and for this typical actually a geometric progression series? So first thing, we should have to look at the first term, which is given as 9. And what is the common ratio? The common ratio is given as negative 6, and divided by 9. And that is has to be given as, so we'll have it as, we have here should be a 3 should be given as 2. This is 3 because the common factor is given as 3. The number that can be entered into a 6 and also 9 as well. So now which means the common ratio is given as negative 2 over 3. So that is the common ratio. So now since the common ratio is less than, that should be 1, then the formula to be used to have the sum of actual terms will be given as, now the first term times 1 minus the common ratio to the power n, and that should be that divided by 1 minus r. So this is the formula that should be used. Now try to have the sum of actually 30 terms there. Also try to have the sum of 10 terms, and even the sum of, let's say, 40 terms, and for that case. So now let's say we have this as another case, assuming that we have the typical geometric progression series given as, let's say, x and plus 2, comma, let's say x plus 5, and let's say comma x, and let's say plus 10. Let's say this is the case, and they're assuming that the values can keep on going in that way. Find the sum of, let's say, 5 times. What is the sum of 25 times? Should be the sum of 25 times, and for this typical geometric progression. So now, as we did in the last time or the previous lesson, we discussed about the geometric progression and the nth term for the geometric progression. You should have to understand that the first thing we should have to calculate the value of x, and in order to have the first term as well as the common ratio, and such that we should be able to have the sum of these terms. So now what should be done? Now we should have to understand that in this case it means the common ratio here is the same as the common ratio there. That's one of the characteristics of the geometric progression series, where at each and every point the common ratio remains the same. So which means we have x plus 5 and that divided by x plus 2. So mind you, in order to have the common ratio, we divide the previous actual terms by the term before it. So which means we have this one divided by this one, and this one divided by this one, in order to have the common ratio, which is the same as we have x plus 10 and that divided by x plus 5. So that would be the case to be looked up to. Then our cross multiplication will have x plus 5 and the times x plus 5. That is the equal to, we'll have x plus 2 and the times x plus 10. So we'll have that understand. So which is the same as x squared and plus 5x and also plus 5x as well. Then plus 25, and which is equal to, we'll have x squared. So just have to simply expand them. We'll have 5x. There I'll have it as 10x, and we'll also have it as 2x, which is plus 20. So we'll have plus 20. Now we should have that understand. Then the further simplifications will follow that. We'll have it as, you understand that this one will cancel. Then we'll have the like terms there, that will be given as 10x. 10x plus, we have 25, which is equal to, now 10x plus 2x, that will be given as, should be 12x. Now have 12x, and the plus should be 20. Now we'll have the like terms. That will be given as 10x minus 12x. That is equal to 20 and then minus 25. And what will go up next? And of which we can have it as, now this is negative 2x. That is equal to negative 5. So in this case, the common ratio, it is given as 5 over 2. So that's the value of the common ratio, as you can see. That should be the value of x, not common ratio. Sorry for that, will be the value of the x. We have it as 5 over 2. So let's substitute actually for x in these actual terms. We should be able to interpret what is really there. Now for instance, we have x plus 2. That is the same as now 5 over 2 and the plus 2. And what is that? We have it as 2. Now this is 4 and plus 5. And which is the same as 9 over 2. And we should also go for the other one. So now let me have it this way. We have it as 9 over 2, which is okay. Then also we have x plus, now should be 5. You know, this is the same as 5 over 2 and the plus 5. Then now what is that one? Now have it as, we have here 2, that will be given as 10 here, and we have 5 plus. That is the same as 15 over, and that should be 2. So which means we have it as that. So this is 15 over 2. So in this case, we are remaining with the other actual part, and which is for x plus 10. It is the same as 5 of, mind you, we are just substituting. Where there is x, we're having 5 over 2 in order to interpret the given actually terms in terms of x. So this is 2 here, we have it as plus 20, and this is 5. So which means we'll have x plus 10. It is the same as 25 divided by 2. So those are the terms that have been given, and upon substituting the value of x in that case. So which means we can be able to interpret the given actual terms, and with respect to the way we have created them here. So which means the first term is given as 9 over 2, and the other one is given as 15 over 2. Then we have 25. We have 25 over 2. So these are the terms of interest you should know. Then what was the question? We are looking for the sum of 25 terms. So in this case, we should have to understand that the number of terms is given as 25. And now what is the first term? We have it as 9 over 2. So now the first term is given as 9 over 2. And what is the common ratio? We have it as 15 over 2, and that divided by, it should be 9 over 2. And of course this is the same as 15 over 2, and it times 2 over 9. So this one will cancel, and of which you have it as 15 over 9. And I may think of having that as the decimal number, and in order to easily working it out, in order to properly working that one with. So 15 divided by 9, that is 1.666, which is the same as the common ratio being given as 1.6, let's say 7 in this way, again that way. So now the common ratio is something which is greater than 1, so which means the formula for the sum of terms also matters as well, 1.67, and that is the value which is greater than 1. So now what will go up next? Now we'll have to present the formula for the sum of 25 terms, and which is given as the sum of n terms, and looking at the nature of the common ratio, it means to have it as the first term times, now have r to the power n minus 1 divided by r minus 1, because we have the common ratio which is greater than 1. So that's the formula we should have to use. So you can pause the video and solve for that. Now let's say we have the actually nth term. Let's say we have the nth term of a GB being given as, let's say, 12 to the power n minus, let's say, 4. What is the sum of, let's say, 20 times if this is the case? We are being given the nth term for the actually geometric progression, which is 12 to the power n minus 4. What is the sum of actually 20 times for this case? Now you should have to understand that the nth term formula provide us a pathway to have the term on whichever the position of our interest. Now for this case, in order to have the sum of 20 times, we need to have the first term, and we need to have the common ratio as well. So now in order to have the first term as well as the common ratio, which you just have to look for the first actually 3 times or the first 2 times, and those terms will help us to have the first term as well as the common ratio. So now let's start it up. In that case, since we have been given the nth term formula, we'll be looking for the first term, and for that particular geometric progression. So the first term is expressed upon having the number of terms equal to 1, so which means we have 12 to the power 1 minus 4, which is the same as 12 to the power negative 3. And using the laws of indices, this is the same as having it as 1 over 12 to the power 3. So what is 12 to the power 3? Now we'll have it as 12 to the power 3. That will be given as, now we'll have it as 1 over 17 28. And that should be, let me have it proper here. Should be 1 over 17 28, and that is the first term. Then I wish to have the second term. The way we'll have to use the nth term, it is also the same way we used to make use of, the way we make use of the nth term. The way we should have to make use of the nth term formula, the way we should have to make use of the nth term and for the actual geometric progression, it is the same way we make use of the nth term formula for the actual arithmetic progression. So nothing different. Then now we need to have the second term. So now the second term will be expressed upon having the number of terms given as 2. So which means we have it as 12 to the power 2 minus 4. That which is the same as 12 to the power negative 2. That which is the same as 1 over 12 to the power 2. So what is it 12 to the power 2? So now 12 to the power 2, we'll have it as 144. So which means the second term is given as 1 over 144. And in this case, let's also go for the third term as well, for the sake of convenience. So in that case, the third term will be expressed upon having the number of them given as 3. So which means we'll have 12 to the power 3 minus 1, actually minus 4. That which is the same as 12 to the power negative 1. That is the same as 1 over 12, according to the laws of indices. So make sure that you are very familiar with your laws of indices. So in case the laws of indices are problems for you, just have to go through my video list, then you come across the video discussed about the laws of indices, so you'll be helped there. Now we have the third term that is given as 1 over 12. So now we can be able to restart the first 3 terms, and with respect to this actually nth term in that case. And let me have to list them up. So in this case, we have the first term, 1 over 17, 1 over 17/28, and our comma, we have 1 over 144, 1 over 144, and also comma 112, actually 1 over 12. And the C, they can keep on going in this case. Now we are on the verse that we can be able to have the first term and also the common ratio as well, and in order to have the sum of 20 times. So try to have that at your own time in that case. Let's say this is also the case, assuming that we have the nth term formula for a GB. Let's say it is given as a 3 to the power, let's say 2n plus 5. So now, what is the sum of, let's say, 50 times? Should be 50 times. And for this actually geometric progression series. Actually for the geometric progression with nth term given as that. And also, how about if we have the nth term given as, let's say, a 5 to the power, let's say, n square? What is the actual sum of, let's say, a 70 times? And for this actually particular geometric progression with the 30 nth term. So you just have to know how we can be able to work it out in that case. So now let's see how we can be able to go for these actually equations. So now the first question says that the 15th term of a GB is 20, and the 12th term is 41. Find the sum of 21st terms. So now the essence behind is that we have been given that the actual 15th term is given as 20. And what is the formula for the 15th term of a GB? It is given as AR to the power 4, which is given as 20. So that is the first actually equation you should have to keep. And also you should have to consider the other part of the question. And what is that part? The question says that then the 12th term, then the 12th term is 41. So which means we'll have it as which means we'll have it as end up being given as 41. Okay, what is the formula corresponding to that? So which means it will be given as AR to the power 11, which is equal to 41. So this is the equation number 2. And for that case, you'll be able to solve the values of the common ratio as well as that of the first term using substitution method, or you can use the ratio technique where you have the ratio of the second term to the first term. And let me just have to start it for you. So in this case, what happened is this. So make sure that before you go for this lesson, you have gone through the lesson we discussed about the nth term formula of a geometric progression, of which I guess that's what you have done. So which means I'll have a second equation divided by a first equation. That's what you call the ratio technique. Now which means I'll have here as 4. So I'll have here 4, and I'll have 20 here, and this is the 4th one. Then we'll have the ratio of the two actual equations, and of which this and this one will cancel. And also this and this one will be given as r to the power, and that should be 7, and that which is equal to 41 divided by 20. Then you should have it as which means we'll have it as r to the power 7. So it should be r to the power 7, which is equal to, what is 41 divided by 20? If I will think of expressing that as a fraction, actually as a decimal number. So now 41 divided by 20, we'll have it as 2.05. So 2.05. So it should be 2.05 in that case. Then what go up next is introduce 7th root both sides in order to solve for r. So have 7th root, which is 2.5. Then you'll be able to solve for r in this case. Just have to know how to make use of a calculator. Then you'll be able to solve for r, then substitute into the formula either the first equation or the second equation. You'll be able to solve for the corresponding first term. And upon having the value of r, then you see which formula should we use in order to have the sum of 20 times. And let's go for the other example here. Given that the ratio of the second term to a 7th term of a GP is 81, should be to 12. Then find the sum of 40 times. So what is the message being depicted here? So now in this case, it is the same as the second term. It is given as 81. Then the 7th term, it is given as 12. Then you can be able to have the sum of 40 times in that way. There's nothing to be scared with there. It is another orientation of giving you something like that, because it is the same as the ratio of the actually 15th term to the 12th term being given as 20 to 41. It is the same as that. So there's nothing to be scared with in that case. Now let's go for actually this case. Now given that the sum of 10 times of a GB is 50, and I find the sum of 16 times if the third term is actually 8. So what should we do there? So in this case, according to the information given, now we'll have to interpret the way the information is being presented. Now we are sure that the sum of should be 10 times is given as 50. And on the same case, we have the actually 30 term, and which is given as should be 8. Now we should have to find the sum of, now should be a sum of 16 terms. So how should you have it in that way? So what is the formula for the third term? We have it as AR square, which is equal to 8. So this is the equation number, should be equation number 2, because this one will have the first equation first. So now, what will be the formula for the sum of terms that we are going to use and for that case? So you can be able to use any formula and for the sum of actually terms there. So which means corresponding to which means actually we'll have it as 50 is equal to, now use the formula, whichever the formula, either the first formula or the second formula, because we are not so sure whether the common ratio is less than 1 or greater than 1, but we just have to use any equation. So have the first term, let's say 1 minus r to the power n, which is given as, that should be 10, that divided by 1 minus r. So in this case, you'll be able to have this as the second equation, and thereafter you have the common ratio as well as the first term, where you'll be able to have the sum of 16 terms. So try to have that. Of course, I may need your responses in the comment section below on the progress of that actually a question. So don't forget to subscribe my YouTube channel so that this kind of stuffs should keep on being created. Thank you.